All right, Mr. Ahmed here for 3.2. Just starting off on this first page, we're going to be working with postulates and theorems about angle pairs, and we're going to start with a little investigation. And what we have going on here is we have our two lines and our transversal T, and we're going to look at angle 1 first. So angle 1 is looking to me like it's approximately 80 degrees. All right, so I estimated 81 at about 80 degrees. I know it can't be 90 because there's no box there, so that's why I went with about 80. It's probably a little bit bigger, but we're going to go with about that. Now it says to place angle 2 so that it's corresponding with angle 1. So for it to be corresponding, I have to go to the other cluster, which is over here, and we're above and to the right, so this would be angle 2. Now, to me, this one looks like it's probably about 150 degrees. And the question that we have is, are they congruent? Well, no, they are not. One's 80, one's 150. Now, for them to be congruent, this line would have to shift this direction until it looks something about like this. Once that line would look about like that, then they would be congruent. So for that to happen, these two lines have to be parallel. And once they're parallel, the corresponding angles will be congruent. So the lines have to be parallel. So that leaves us to our first postulate, which is the corresponding angles postulate. And that states that if there are two parallel lines, P and Q, cut by a transversal T, then all the corresponding angles are congruent. Now we only listed angle 2 and 6 in this case, because once I listed too many, then there'd be too many to look at, but every pair of corresponding angles is congruent. In a similar manner, if two parallel lines are cut by a transversal, notice the indication, they are parallel. If that happens, alternate interior angles are congruent. We abbreviate that, the alternate interior angle theorem. In a similar manner, alternate exterior angles. If two parallel lines, these are parallel, cut by a transversal, alternate exterior angles are congruent. So angle 1 is congruent to angle 8, and then these two would also be congruent as well, but we didn't list those out. And finally, this is the most commonly forgotten, most difficult one, same side interior angles theorem states, if two parallel lines are cut by a transversal, the same side interior angles are supplementary. So those ones are not congruent. One's obtuse, one's acute. Those two are going to add up to 180. So we need to memorize these four properties. And first, we are told that angle 3 is 42 degrees. So I'm going to pull out a different color so it stands out a little bit better. So if angle 3 is 42 degrees, we're supposed to find all the other angles. Now we can find all 8 of them because these lines are parallel. I'm going to start with vertical angles. 3 and 1 have to be congruent, so angle 1 is 42 degrees. These two have to add up to 180. 180 minus 42 is 138. So angle 2 is 138 degrees. And then we have another pair of vertical angles, so 138. Now for us to get the second cluster, we have to look at some alternate interior or corresponding. Since the lines are parallel, alternate interior angles are congruent. So angle 5 has to be 42. 8 has to be 138. That corresponds with angle 4. 7 has to be 42, vertical angles again, or you could say alternate exterior angles, lots of options. And lastly, angle 6 is 138 degrees. So out of all 8 of these angles, when these two lines are parallel, there's only 2 different numbers, okay? 2 different values. So we're going to find some different values and state our reason. So the first thing we have to do is identify if the lines are parallel or not. So in this problem, it says R is parallel to S, so I'm going to put my parallel marking on with the arrows. Since those two lines are parallel, I know that we have some congruent angles. In this case, 113 and 3x minus 4 are the two that were given. Those are alternate exterior, different clusters, both outside, opposite sides the transversal. So 113 has to equal 3x minus 4. We can solve for x by adding 4. 117 equals 3x. And when we take 117 divided by 3, we get 39. So x is equal to 39. And the reason is they were alternate exterior angles. So that was the alternate exterior angle theorem, which states If two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. The next one, I am told T is parallel to R, so I'm going to mark T and R as parallel. And here, when I look at the angles, I have one outside, one inside. They're not corresponding, so they aren't congruent. So I have to find a new way to do this. And there's numerous options I can do. The one I'm going to approach is I'm going to use a vertical angle pair. 3x minus 7. These two angles are vertical angles, so they have to be congruent. So the first reason is vertical angles are congruent. Then from there, I can now state that these two add up to 180. The reason why those two add up to 180 is because they're same side interior angles. So I'm going to use the same side interior angles theorem. So my equation would say 3x minus 7 plus x plus 5 equals 180. Now we can solve, combine like terms. 4x minus 2 equals 180. 4x equals 182. And 182 divided by 4 is 45.5. So we did get a decimal. It is possible. Okay, so we listed our two reasons. First, we use vertical angles. Then we use same side interior. So you might have to take 2 steps. And lastly, I'm going to do a proof. So this is kind of a 2-column proof on my own. All right, so it says, prove the theorem that states if two lines are parallel and cut by a transversal, then the alternate interior angles are congruent. So I need my given first. My given is that P is parallel to Q. And that's what I know. I need to prove that the alternate interior angles are congruent. The alternate interiors are 1 and 2, so I need to prove angle 1 is congruent to angle 2. Statements and reasons. Always start with the one thing I know. Step 1, I know line P is parallel to line Q. That is given. Now I'm going to use it. If that is the case, I can't use the alternate interior angles theorem because that's what I am proving. So I need to use the corresponding angles first. I know that angle 1 is congruent to angle 3. Angle 1 congruent, angle 3, reason, corresponding angles, and that was a postulate. Okay, so I know angle 1 and 3 are congruent. Next thing I know is I know that angle 3 and 2 are congruent. Reason why, they're vertical angles. Vertical angles are congruent. Step 4. When I look, I see my 3's match. I can use the transitive property of congruence to state that angle 1 is congruent to angle 2, which were my alternate interior. And I'm finished. My statement has been proven based off the transitive property of congruence. So that was a nice little proof. Hopefully as we keep progressing, we'll be able to handle ones like this. The hard thing about this one was not just saying angle 1's congruent to angle 2 because we already knew that, but we were proving that theorem. That's how I proved the theorem, by only using the postulate, which I knew before that. All right, that's all we got for today. Have a good one.